This will be the first video for the review of Unit 14 over logarithms for your Unit 14 test. We'll split this into several videos. So we'll see how many we get through in this one. So question 1 says, sketch the graph of f of x equals log base 3 of x minus 2. So we have followed the same process when we've worked with exponentials and now with logarithms as far as the graphing goes. So we list what happens to x, what happens to y. Well, this negative 2 there with that x moves our graph to the right 2. It's always left and right opposite of the sign when you're in here with x. And then there are no other changes. There's no addition out here. There's no multiplication anywhere. So y, there will be no changes to the original y's. So then we make our original graph. And for logarithms, we use the points 1, 0 and base, 1. The base here for the logarithm is 3. So base, 1 in this case is 3, 1. And then we have the vertical asymptote of x equals 0. That's our original. And then we apply these transformations that we've identified over here to those points. So the x's go to the right 2. So it was 1, right 2 is 3. Was 3, right 2 is 5. Was a vertical asymptote at x equals 0, right 2 takes us to a vertical asymptote of x equals 2. And the y coordinates didn't change. We identified that here, so they stay the same. Once we have those points, we can sketch our graph from the new table setup that we have here. So vertical asymptote, we'll put that in first here at x equals 2, label that. And then we have the point 3, 0 right here and 5, 1 right here. So based on that information in the vertical asymptote, graph has to be shaped this way. We'll label that point 5, 1 and we'll label that point 3, 0. And that's it for problem 1. Problem 2 here says sketch the graph of f of x equals log base 3 of x plus 2. So follow the same process. What's happening to x? What's happening to y? There are no changes to x here. Nothing's going on there. So we'll write none for that. And the y's will be shifted up 2 because of that plus 2 there. So up 2. We'll make our original graph. It is always 1, 0 and base, 1. Base is 3 here. So 3, 1 there. And vertical asymptote starts at x equals 0 originally. And now our new table. So the x's, I'm just going to rewrite all of those. There are no changes there. The y's just need to go up 2. It was at 0, now it's at 2. Was at 1, now it's at 3. We just add 2 to those two numbers. Then with that information, we can make a sketch of the graph. So vertical asymptote is the y-axis, x equals 0 here. And then we have the point 1, 2 right there and 3, 3 here. Based on that information in the vertical asymptote, has to be shaped like this. And we'll label that point 3, 3 and this point 1, 2. And we're done with problem 2. Now for problem 3, sketch the graph of f of x equals negative 2 times log of x plus 5. So same process. What's happening to y? What's happening to x? X, no changes. Nothing's going on here with x. Y will be multiplied by negative 2. So we'll take all of that at one time, multiply by negative 2. It's going to be a reflection and a vertical stretch. That's what it's actually doing. But when we're making these tables, we can accomplish all of that at one time by multiplying by negative 2. I abbreviated multiply there. And then this is an up 5, that plus 5 there. We need to follow order of operations, so we'll multiply those coordinates, y coordinates by negative 2, and then add 5 to them. It's important that we do that. If you do the opposite, you'll end up with the wrong graph. So the original graph is always 1, 0 and base 1. The base is implied to be 10 there. There's no base listed, so for a logarithm, no base listed. It defaults to base 10. It's implied to be base 10. So x equals 0 is the vertical asymptote. That's the original, now the new. So x's are staying the same. I'm just going to rewrite all those. No change to x. The y's multiply by negative 2. So 0 times negative 2, still 0. Up 5 from there takes us to positive 5. Multiply 1 here by negative 2, that's negative 2, and then up 5 from there takes you to 3. So we have everything we need to make a rough sketch of this graph. I don't know why I wrote x equals 10 there, but that's wrong. It's x equals 0. There were no changes to that. So anyway, back to this. Vertical asymptote x equals 0. We have 1, 5 here and 10, 3 here. Based on that information, it has to be shaped like this, and it will cross the x-axis out here somewhere. So that point is 10, 3, and this point is 1, 5. And then our vertical asymptote was here at x equals 0. Alright, that's it for problem 3. Problem 4 here, sketch the graph of f of x equals negative log base 4 of x minus 2 plus 1. So follow our same process. What happens to x, what happens to y? So x will be right 2 because of that subtract 2 there. Remember, it's always left and right opposite of the sign with x. The y's will be opposite because of that negative right there. I'm going to abbreviate opposite there. And then up 1 because of that. We need to follow order of operations. We're multiplying the originals by negative 1 because they're opposite, and then we'll add 1 to move them up 1. So let's make our original table, and that is always for logarithms 1, 0, and base 1 are the anchor points that we use. And the new table, so the x's go right 2, so 3 and 7. Right 3 from 1, right 2 from 1 is 3, right 2 from 4 is 6. Okay, that would be 6, not 7. And then the vertical asymptote is usually x equals 0. It goes right to x equals 2. All right, there we go. Now, y's opposite of 0 is still 0. Up 1 from there takes us to positive 1. A y-coordinate, original y-coordinate of 1, make it opposite. That's negative 1, and then up 1 takes you to 0. So there's all of our information that we need. So x equals 2 is the vertical asymptote here. Label that as 2. And then 6, 0 out here and 3, 1 here. Based on that information in the vertical asymptote, it has to be shaped like this. We'll label those points 6, 0, and 3, 1. And that's it for problem 4. Okay, number 5, express the common logarithm of 3. So that means this, log base 10 of 3. Common logarithm means base 10 in terms of natural logarithms. So we're going to use natural logarithms would be ln. So we're going to put the new base that we want, natural logarithm, on in the numerator and denominator here. We're just using the change of base. The 10 is the subscript here, so the way we remember that is it goes below, and then the 3 is just listed a little above, so we remember that it goes here. This is just the change of base formula. The way that we discussed it in class is the subscript 10 is a little lower, so you can remember that it needs to go down here, and whatever the argument of the logarithm is a little higher, so it's going to go on top. And then you write the new base that you want top and bottom. So the answer there to express the common logarithm of 3 in terms of natural logarithms would be ln of 3 all over ln of 10. All right, let's look at number 6. Question 6 says use a calculator to find the natural log of 47.2. If you put that in a calculator, you get approximately 3.854. We will not be using a calculator on this test, therefore I will not give you a question like this. So let's move on to number 7. Number 7, which of A, B, C, and D in the equation below must be positive? Okay, well, we have discussed this before that we cannot take the logarithm of a negative number, so that means C has to be positive, this right here, the argument of the logarithm, and we can't have logarithms with a negative base, so C and B must be positive in this setup. A can be negative, D can be negative, but the base and the argument of the logarithm must be positive. All right, let's look at 8. Number 8, express g of x equals log base 3 of x plus 9 in exponential form. So we'll just apply the loop rule, so it would be 3 to the g of x power is equal to the argument x plus 9. So that is it. 3 to the gx equals x plus 9. And don't let this confuse you. G of x, you could put a y there, you could put f of x there, whatever. It's going to be the, whatever is in this spot will be the exponent right here. So 3 to the gx equals x plus 9 answers problem number 8. Alright, that's it for this video. We'll pick up question 9 in video 2.